Okay, let's take a look. This is the second set of practice problems I was asking you to do. Practice 16B. And don't do numbers 9 and 10 because they'll melt your brain. Okay, so let me take care of this first. Hang on, I gotta make this bigger. Hang on. Okay, sorry about that. So let's remember that the equation that we're using here is always the same. CP equals, I'm sorry, Q, don't do that. Even the pros make mistakes. Q is equal to CP times M times delta T. And I like this version best because it's easiest to flip around. So for example, here we are in practice 16B, and it's asking for the specific heat. That means we want CP. So that means that this version is going to look like this. Q over M times delta T. All right. So all we're doing is entering everything that we have in the equation. We've got energy of 5,796 joules. We got a mass of 201 grams. And we've got a delta T, since we're going from 35 to 57, that's 22 degrees. All right. So let's plug it in. We got 5,796 joules. We've got a mass of 201 grams, and we've got a delta T of 22 degrees Celsius. So without a calculator, you would be in bad shape. 5,796 divided by the quantity 201 times 22, and we get 1.31. And notice that because the units don't cancel, our answer is in joules per gram degrees Celsius. Easy peasy. Same thing. Here we go. This one is asking for specific heat. We already did that, so we know exactly how this equation is going to work. We have 458 joules. Sorry. 458 joules with a mass of 120 grams, and it went from 15 to 30 degrees Celsius, so our delta T is 15. So we're going to say 458 divided by the quantity 120 times 15. I get specific heat of 0.254 joules per gram degrees Celsius. All right, getting the hang of it, right? So what's nice about number 3 is that it's asking for heat, and that is our original version right there. Q is equal to CP times M delta T. So we're asking simply for the Q, CP times M times delta T. It gives us a specific heat. This is ethanol, 2.44 joules per gram degrees Celsius. We have a mass of 28 grams. And we have a delta T of 15 to 65.5. So let's be careful. 15 to 65.5. That should be, I just want to double check, 50.5 degrees Celsius. So when we do this, degrees Celsius cancels, grams cancels, leaves our answer in joules, which is just what we wanted. 2.44 times 28 times 50.5. We get 3,450.16 joules. Same one for number 4, where we have how much energy is absorbed. So our Q is equal to CP times M times delta T. We have a specific heat. This is of steam, and so the specific heat for water is going to be different. It's not 4.184, it's 1.87 joules per gram degree Celsius. Our mass is 20 grams, and our temperature is going from 283 to 303. So that is a delta T of 20 degrees Celsius. 1.87 times 20 times 20. Pretty easy, 748 joules. Okay, number 5, same thing. When 15 grams of steam drops in temperature, how much heat is released if we go from 275 to 250? So sorry if I'm getting to be old hat here, but pretty easy stuff, right? 1.87 degrees. Whoops. See? Even the pros make mistakes. Joules over grams degrees Celsius. We have a mass of 15 grams. We're going from 275 to 250. That's a delta T of 25 degrees Celsius. Degrees Celsius cancels. Grams cancels. Leaves our answer in joules. 1.87 times 15 times 25 is 701.25 joules. All right. Last one on the front page. Things are going pretty quickly now because these are all set the same way. This is looking for energy. Q is equal to Cp times M times delta T. Don't want that. We have a specific heat. It is 4.184 joules per gram degree Celsius. Some people leave off the 4 and just use 4.18. Our mass is 120. Sorry, my pen is being weird. 120 grams. And we're going from 2 degrees Celsius to 24 degrees Celsius. That's a delta T of 22. So 4.184 times 120 times 22 is 11,045.76. Let's just call that 11,046 joules. All right. Okay, backside. How much heat in joules is given off when 85 grams of lead cools from 200 to 10 degrees Celsius? And here is lead's specific heat. All right, last one in this version, Q equals Cp times M times delta T. Gives us a specific heat of lead, 0.129 joules per gram degree Celsius. We have a mass of 85 grams. And we're going from 200 to 10, so that is a delta T of 190 degrees Celsius. 0.129 times 85 times 190. And this is 2,083.35 joules. Right off the bat, you can see right here how dangerous water is. See that? This only slightly higher mass of water and a delta T of 22 degrees Celsius gives off 11,000 joules, whereas lead, cooling from a much higher temperature, doesn't give off nearly as much heat. That's why steam is so dangerous, why it's so powerful. Okay, last one, and then I'm done. All right, number 8. A certain mass of water is heated with 41,840 joules, raising the temperature from 22 degrees Celsius to 28.5. Find the mass. Hey, a new version. All right, so this is why I like to use this layout for this equation, because it makes the arranging all that faster. I think anyway. So mass is going to be equal to Q over Cp times delta T. We know we have 41,840 joules. Our Cp, it tells us right there, 4,000. I'm sorry, 4.184 joules per gram degrees Celsius. And we're going from 22 to 28.5. That is a delta T of 6.5 degrees Celsius. Degrees Celsius cancels, joules cancels, leaves our answer in grams, which is just what we want. So we're going to say 4,840 divided by the quantity, 4.184 times 6.5. And we get 1,538.5 grams. All right. Only do 9 and 10 if you don't value your brain, which I think you all do. This is something that I assigned last year, but we're not going to worry about it this year. All right. If you're curious, I'll post the answer key, but you're not going to see anything like this. Okay. So that's all I got. See you guys on the next one.